Okay, I think we'll get started. So today we're going to look at the first part of our LuckFox RS232 communication lab here. So this was actually asked for by Jirapat Dennett, one of the viewers of some of the earlier videos on the LuckFox. And he was interested in RS485. These are very similar protocols. I looked all over the lab and I didn't have anything that was an RS485 communication. I did find, I certainly had some that were RS232. And so I'm going to focus here on the RS232. They're very similar protocols. This is an earlier one by quite a number of years. This is a later one. This primarily runs between a -9 volt as a low signal, as the low, and the +9 volts as the high. It idles low and then goes high for sending characters such as ASCII characters. It is a UART, a universal asynchronous send and receive, but in this video I'm going to reserve calling UART the TTL 0 to 3.3 volts coming from the LuckFox, and I'm going to talk I'll say specifically RS232 communication to mean the -9 volts and the +9 volts. This is relative to a ground, so these wires go independently. So one of the disadvantages of RS232 is that it can be susceptible to noise. Another disadvantage is that you can only plug in one device between the two. And then the other advantage is you can't string a very long cable. So along came RS485, which addressed these. It builds its communication based on a voltage difference rather than -9 volts compared to ground and 9 volts compared to ground independently. It allows for multiple devices to be connected to the same bus line, and then it allows for much longer cables. I think the RS232 has a limit of roughly 50 feet, and the RS485 I think can go 1,000 feet or something like that. So if you have to extend much further away from your device, you would use that. I'm going to focus this on just the LuckFox interaction, and so we're going to look at we'll go on the whiteboard. We'll look at a circuit that I built for out of transistors to make this conversion from the 3.3 volts, the 0 to 3.3 volt communication, to the -9 volt to 9 volt communication. Then we have to convert that back if we want to be able to talk between devices, so that we can transmit with our LuckFox, get that converted to 9 volts, ±9 volts, and then have that ±9 volts coming back from a device be converted back to UART. So we're going to do that here. We're just going to be using one UART. We're going to first send a character to a scope, so we'll be testing this circuit. Then we'll write a loopback that will test both of these circuits, where the UART transmits, it gets converted to RS232, and then we convert it back to UART. So that will be the nature of part one, and then in part two we'll bring in more. We'll communicate from one LuckFox to another, and we'll maybe communicate with some other devices if we can. There's a lot to the RS232 and RS485 protocols. They're such important protocols in the history of electronic communication. Less used now because they're the more modern techniques, but a lot of old equipment still talks about it. So a couple of good overviews. There's two videos here, and they'll be linked in the description of this video by the YouTube channel Real Pars. One talks about RS232 and the other talks about RS485. And then as a compare and contrast, the real-time automation YouTube channel goes through and compares both of these techniques. So there's also just a whole host of other information out there on YouTube if you're interested in the specific details of these communication protocols, which I won't be getting into here. All right, so I'm going to pause the video now and write out the circuits on the whiteboard, and then we'll walk through those circuits. Okay, let's get into the circuits now. So let's look at the first part. This is going to be converting the UART, and by UART here, I'm meaning very specifically the TTL UART coming from the LuckFox. So high is 3.3 volts, 0 is low. So and 0 volts is low. Protocols such as RS232 are also UART, they're UART, but in the context of this video, UART is going to be the TTL, and then I'm going to always just say RS232 communication, meaning specifically the plus or minus, usually 9 volts. Okay, so a couple of things to note here. There's an inversion of high and low, so a plus 3.3 volts in the UART, the TTL UART, corresponds to the minus 9 volts in the RS232 and vice versa. So the purpose of the circuit, then, we're going to need to convert and invert. So that's can be done with transistors. There's a couple, one of the things, the wrinkle that gets thrown into this is the transistors usually work by comparing the base to the emitter versus a ground. And what happens with the RS232 with the plus and minus 9 volts instead of a 0 and 9 volts adds a little bit of difficulty, which we'll talk about here in this circuit. Okay, so let's kind of work through the logic here, and as we do, I think you'll start to see the purpose of these transistors. There are probably some other setups, and but this works just fine. I didn't put any capacitors in here to help eliminate high frequency noise, but with this swing of 9 volts and not extending over large cables, this circuit works really well, and it is as simple as I could come up with. If you've got some other ideas for better circuits, for those viewers who might have to be really worried about noise or other things, please feel free to mention that. I'm certainly no electrical engineer. Okay, so let's just look at the flow first. We've got the LuckFox coming in here. We'll go into a NPN transistor, and I'm going to use the 2N3904. This doesn't look like a 9. I'll fix that. 3904. Couple of protection resistors, 10Ks, so we need a lot of 10K resistors here. We'll have kind of a cascade of NPN, NPN. So this is the same, these are both the same transistors, and that will serve to do the conversion. Now to invert, we actually need a third transistor here, and we're going to actually go with a PNP. And oftentimes, I guess, although this is absolutely not necessary, a good combination pair would be the 3904 and the 3906, the 3906 being the PNP, both very inexpensive transistors. This is tied to, also tied to the positive line, so that could be a little bit confusing, although it's always set up in this way for a PNP. Okay, so let's follow the flow of the logic, and I think you'll see why this circuit works well. So we have really two things happening here. We can either be high or low. So let's trace that through. So let's start with a 3.3 volts here. So we're going to be high with our UART in. So that means from base to ground, we have a voltage difference there, and so we'll get a current flowing through here, which will open up this transit, which will I should say it reverse, will sort of allow current to flow through here. So we're going to call this, let's call this like C for closed. Let's call this like W for wire, I guess. So in our minds, we can think of this now, because there's current flowing through here, effectively this is acting as a wire. And so what that's going to do is it is going to ground this side, and so this will be 0 volts here. Now, if this is 0 volts, then will be 0 volts coming into the base here, 0 volts here. So there will be no current flowing. And so this will be like an open. So if this is like an open, this is acting as a really big resistor here. So this voltage up here will be 9 volts. Okay, so with this particular cascade, what we've done is we've converted, so this is the converting part, we've converted 3.3 to a plus 9 volts. And that's fine, but to be consistent with the RS232 protocol, we really want 3.3 to be minus 9 volts. So that's what this last stage is to do. This is to invert this. So along comes this plus 9 volts over here. And, oh, I should label this. This is a 10K as well. So 9 volts here. Now look at this is the strategy here with tying this to the 9 volt rail, is that there's no difference here, so there's not going to be any current flow here, and so this is going to act as an open, right? So there's no current flow, even though there's 9 volts applied here, no current flow. So what that does is essentially open this up, and so this is tied, although it's 10K resistor, this is an infinite resistor, so this is going to be minus 9 volts. And so for an input of 3.3, we get our minus 9 volts. So we have confirmed that. So let me go ahead and erase this set, and let's work that through now with the low voltage, with the 0. So just erase that. Okay, so we've confirmed that the high gives us the minus 9, the high of the UART. So let's go to 0 here. So now we bring in 0. Now there's no voltage difference between the base and the emitter, so this is acting now as an open circuit. And so if that's the case, then this is going to be the full 9 volts. If we're 9 volts here, then we're 9 volts here. And now we do have a voltage difference. And so this is going to allow current to flow and then open up this channel for flow. And so this will be closed here. Or sorry, we were using W for wire. So this will act as if it's a wire, right, which will pull this side to ground. So we've got just now a 10K here, and this is connected to ground because that's acting like a wire. Well, if that's ground, if that's 0, that's 0. And now, again, the strategy of this comes into play. Now there is a difference. So current will flow through this transistor and make this act like a wire. If this is a wire, this is a 10K, this is essentially 0, and so that's going to pull this guy to a plus 9 volts. And so what do we see here? We entered with a 0, and we exit with a plus 9. And so we have got the right logic here. So we have done an invert, So we've done a conversion. So these are the conversion, and this is the inversion step. Okay, so that is the UART to RS232. So our TX line coming from the LuckFox will go through this circuit, and then you've created basically an RS232 TX line. Okay, so now let's go the other way. Let's take and pull this RS32 plus or minus 9 volts back to a 0 or 3 volts. So simpler circuit here, but we do have another component coming in. This is a diode, and the reason we have the diode, and this is another part of the trickiness of this, instead of with the RS232 having the minus 9 volt and the plus 9 volt instead of 0 and 9 volts, for example, we have to handle that negative 9 volts, which has sort of been the pesky problem throughout here. And again, that happens here. So we're gonna have a minus 9 volt come in here, and we can't put that on the base here. So it really can only tolerate a small negative voltage here, or it damages the transistor. So, oh, and this transistor here is the same as over here. This is a 2N3904. So it's NPN style transistor. But other than that, it's just a one transistor that's tied to the LuckFox 3.3 system bus. So let's just run through the logic again here, and I think that will help you see the flow of the circuit. So if we come in with a minus 9 volts here, then that means we're presenting a minus 9 volt across this diode. And so the diode will allow current to flow in this direction, but it will not allow current to flow in that direction. So here we can flow current. Positive. The ground is more positive than this minus 9 volts. So essentially, that shorts this, and what it leaves over here is essentially 0 volts. Right? It takes this to ground. So because we have this diode here, it protects this end and allows just a basically 0 volts there on that transistor. And then this is ground. So this is a difference of 0 between the base and the emitter. So this is going to be acting as an open circuit. If that's open, then this is an infinite resistor. This is a 4.7 k ohm. Forgot the ohm. And so with minus 9 volts in, we get 3.3 out because this is acting as an open. So this is pulled up to 3.3 volts. Okay, let's look at that now in the opposite direction. So we have to double check that even though it works for one logic level, it needs to work for the other logic level. So let's try a plus 9 volts here. So if I go plus 9 volts, then I'm a plus 9 volts over here. Well, current would want to flow this way, right? Because now that junction would be higher in voltage than the ground, but current can't flow in that direction. So that's acting as if it's not even there. And so that's going to present a 9 volt to the base of that transistor. If that's the case, then current can flow here. So that turns this on and makes this basically a wire. And so we've got our 4.7 k ohm up here, got basically a wire down here. So that's going to pull this to 0 volts over here. And we indeed see the right logic. So with these two circuits, you can go back and forth on your transmitter and your receiver for RS232 communication. So we are going to now get into, for this first part, for part 1, we're just going to work with one LuckFox. We're going to see this circuit in action, and we're going to send a character to the oscilloscope and see that it gives the right character on that oscilloscope, and then we're going to do a loop back and receive that same character with our LuckFox. In part 2, we're going to separate those so that one LuckFox can be communicating to another LuckFox, for example, or to another device. So in a use case that you might be interested in, you have these two circuits that you would be dealing with. One to create the RS232 TX line, that would be this one, and then one to receive the RS232 line, RX line. And so again, what we're going to do is we're just going to connect this to that and loop back around within one LuckFox. Okay, let's get to the computer and go through the circuit, and then go through the Python programs that will be running on the LuckFox. Okay, so we'll get into the circuit here. Before we do that, I just want to say a little bit about the power supply. So very simple, can use 9 volts because the RS232 is naturally occurs as a plus or minus 9 volts. So just 2 9-volt batteries here, and have just a simple basic connector, and what you do is you just put the negative lead of one to the positive lead of the other, combine that. So basically combine the batteries in series. And so I just soldered the two together, put some heat shrink over it, and then have one lead here. So this will serve as ground. So this will be grounded to the ground of the LuckFox. And then the negative lead will be minus 9 volts relative to ground, and the positive lead will be plus 9 volts relative to ground. Okay, I'm going to pause the video here, get the power supply plugged into the circuit, and then we'll get into the circuit. Okay, let's get into the actual circuit here. So we've seen now the power supply. This breadboard is going to have the LuckFox itself, and then this breadboard is going to have the UART to RS232 circuit, so taking us from the 3.3 volts to the plus or minus 9 volts. And then this part of the breadboard down here is going to have the RS232 to UART, so the plus or minus 9 volts down to the 3.3 volts. The power supply is situated such that the outermost rail here is going the whole distance of the board is the plus 9 volts. The inner rail here is ground. Then the inner rail on the bottom part of the board here, so I don't have a connecting wire here in the middle, is going to be the 3.3 rail. And then here is going to be the minus 9 volt rail. So the outermost rail on this side is going to be the minus 9 volt rail. So we can see this positive wire, that's the plus 9 volts. This is that combined wire from the negative wire from the one battery and the positive wire from the other. So that is coming here, and then finally this black wire here is the minus 9 volts. This red wire is coming from the system pin, the 3.3 volt pin from the LuckFox, so the 5th pin down on this side, over to, or 5th pin up on this side, I guess, as you're looking at it, and then over to this rail. So that's powering this breadboard. Now let's walk through the individual circuit. So the first thing we have here is the entry. Hopefully you can see my mouse here. The entry of the LuckFox signal. So that's coming from this pin right here. So unfortunately these are both white here, but this white wire that I'm holding is now coming into this 10K resistor right here. And that is going to then the base of the first NPN transistor, the 3904 transistor. Now, this transistor and the other 3904, they're facing towards the flat side is facing towards the pen. So as we look from bottom to top, it'd be emitter base collector. So here we're in the base. The emitter part is grounded directly, so that is going from the emitter line. This green is taking us from the emitter to the ground, and then the collector has a 10K, that's this one right here, that is taking us up to the positive rail. So this 10K takes us to the +9, and then we're just grounded directly on that emitter. Now coming off of the collector side is another 10K, and that's taking us to the base of the next transistor. So that's sitting right here. And so again, front side facing this pen. So emitter base collector, emitter grounded just like before, and then the collector taken up to the 9-volt rail with a 10K. So very similar situation here, this and the ground here. And again, splitting off of the collector, we have a 10K carrying us over to the base of the PNP. And so we have the 2N 3906 transistor. This is flipped the other way. So the flat side you can see now is on the opposite side of the pen. So now as we go down from the top, it's emitter base collector. So we can see that the we're in this case we are taking that emitter side up to the positive rail. So that's this blue wire, and then down to the negative rail is the 10K here, this 10K resistor right here. And then the output is right here, this gray wire. And so we'll write in a program shortly and send an ASCII character through this and to the scope. But before we do that, let's look at the other circuit, the RS232 to UART circuit. The way we've got this set up here for the first part of this tutorial is we're just going to loop back. So we're going to send some characters to the UART to RS232, and then that will come back and be converted back to UART in this circuit, and then we will send it back on this wire, the receive wire, for the LuckFox. So the LuckFox will just send a message to itself via this conversion, and that will lay the groundwork then for both sending and receiving this information. And thus, when we go on to part 2 of this tutorial, we'll be able to just separate those and talk from one LuckFox to another, or a LuckFox to some device. Okay, so we're going to send this into this 10K resistor, and then we have, as I mentioned on the board there, this diode. I'm using a 1N914, but it doesn't matter too much. This is there just to protect the NPN transistor so that the base never goes highly negative voltage. So with the diode there, it'll probably go to about -7 or 0.7 volts, which is still acceptable. And then we just have a pull-up resistor here, this 4.7K that will pull up to the 3.3 volts. And so on our output, we will get either 3.3 or 0, and with the proper connection to the RS232 protocol. So a +9 is a 0 volts, and a -9 is a 3.3 volts. Okay, so let's move on, and we will do we'll run 2 Python programs, one just a straight output, and so we'll send a character to the oscilloscope, and then we'll run the full feedback loop. Okay, so the first thing we should do is make sure that our UART is set up correctly on our LuckFox. I'm going to be using UART 3 here, and so if you've been following along in the series, that should be activated for you already. But let's go through just to confirm that, and for those of you who are coming in this to the first time, make sure that that's set up to be activated. So it's going to be pin 56 and 57 in terms of how we call the pins in the program, and then physical pins 19 and 20. So that's that confusing two number schemes there. And we want to set it for the UART 3. There's a number of different UART capability, or the LuckFox can do many UARTs, so we want to activate this one. Okay, so let's go ahead and do that. So first thing you might want to do is just go sudo LuckFox -config and then show, and this will show what we have. And look down. This is sort of the layout, the same layout as the pinout we just looked at. And so this is pin 56 and 57. And notice there's an asterisk here. So that means my LuckFox is set up in the UART configuration. So if the asterisk was over here, it'd be in pulse width modulation mode. Notice there's no, by default, it's in just GPIO mode, so the asterisk doesn't show up there. But let's say you don't have an asterisk here, then this program won't work because we're going to be calling the UART. So let's go ahead and we'll go, instead of show, we'll just leave it as LuckFox config. So up will come the configuration menu. We'll go down to advanced options, and then we'll go to UART. And then again, the asterisk is shown. So if you do not have an asterisk here in UART number 3, then just go down to UART number 3, and then you would click enable. And then cancel out of here. And then just check your UART again. You should have an asterisk there now. So I'm going to cancel that again, and then cancel this, cancel. And you may even want to, just for good measure, run the show again. Make sure that you're getting a asterisk there. Then you know your UART is set up. Okay, let's go out and let me clear this, I guess. Let's go out and get our program. So if you can go to Google and then navigate to my website and darrenolmus.com, and then let's go to our LuckFox. So under teaching, LuckFox controller, and that'll get us to our page here. And let's first just do the send. So I'm going to grab this. And again, if you're new, if this is the first one, these are actually Python scripts. You can get them at GitHub as well. On the web here, I just have them as text files, but you'll notice when we open this, it's a Python script. So I'm going to copy this first. We'll go through it. I'll kind of quickly go through it. I won't spend a lot of detail on the program itself, but I'll sort of quickly go through the highlights once we get it set up here. So let's go sudo nano. So this will get us into the text editor. And let's call this RS232 send.py. And then we'll just copy, so just right click and paste, and that should have all of this in here. So a couple of things. We need serial. So again, if you've been following along, you've already got serial installed, but I'll talk about that when we exit out of here. You'll need to, if this doesn't work, this should be the right port, but you may have to make sure that's true in your setup. Again, by default, this should be the right port here. And then we set the baud rate as a very typical baud rate of 9,600. Okay, so a lot of this is just some stuff I had Gemini write this. Does a great job of like filling in all the error handling and all sorts of things. So it's excellent at that. But what we're really concerned with is what it is that we're going to do. So this program is going to ask a user. So it's going to get a user to enter a character, and or any number of characters and transmit that. So we'll just type in say an A, and we'll make sure on the scope that it shows up as a ASCII character A. Okay, so then it will send the byte, and then it will follow that with a carriage return and a line feed. So sort of the character, so that will allow, in principle, although we won't be doing it, will allow for, you know, a message is sent and then breaks that off for a new message and so on. Then it'll flush the serial and be ready to go again, and so that'll just be in a loop until we exit. So that's really what's going to be going on here. A lot of extra stuff here is just the error handling that Jim and I decided to put into this code, which is always helpful because I'm terrible at putting in good quality error handling. Okay, so that is that. So we'll save this, yes. And now what we're going to do here, I'm going to have to do a little switcheroo. Let's run this program, and we'll look at it here on the screen, and then I'm going to switch to view the oscilloscope. So the two leads here to the oscilloscope are here and here, and so we've got the ground, and then we've got the output of the UART to RS232 part of our circuit. So let's go ahead and run this. So we'll go sudo python 3 and then RS232 send, and this is just some of that printer stuff. So let's just type in A, and then it'll send the character A. We can type B, it'll send the character B, and so on. And then we can type quit to close. Okay, I'm going to pause the video here, or actually I don't even need to do that. I can just switch here, I think, to scope. And I'm going to set up a single acquisition. Actually, let me first show something. Stop run. There we go. Okay, so here's ground, and we are. Let me pause this. Okay, so we're sitting low here, and this is my trigger. Also, I apologize for this tutorial is running through all my camera supply, and this camera here is just for the life of me, I'm not able to get a sharp focus on this oscilloscope. So we're gonna have to do the best we can here. Hopefully you can see it well enough. So the you can kind of see the live data coming in. We know that in UART protocol, the idle state is high. In RS232, the idle state is -9. So we're sitting at -9 volts. Looks like this is the zero. It's not. It's actually up here. This is the trigger level. And so we'll send a character, and we'll see swings of approximately 18 volts here. So I'm going to set this now to a single run, and we'll capture our character. You won't be able to see me run the Python program at this time, but I'll just do exactly what we did just moments ago, and we'll see our characters come in. Also, this scope is nice. It automatically reads the UART. So let's go ahead and do that. Put this to a single acquisition mode, and I will transmit character A. And let me move that over just a little bit. Well, let me leave it there, actually. Okay, so hopefully you can read this down here. This is 41, 0D, and 0A. These are the hex values for the ASCII characters. So that's cool about this particular scope is that you could put it into this UART mode and it'll read that. So let me pull up the ASCII characters here, and well, actually I can't do that. Let me show you the ASCII characters. And so we sent, hopefully you can see this, we sent the letter A, and so that's 41, and that's precisely the 41 we're seeing right here. And then what else do we see? Next we see a 0D. So what's 0D? 0D is the carriage return that was in the code. And then finally we see a 0A, and that's the line feed. So that was the actual characters we saw. So let's just send a few more characters. And so let's send a G. Whoops, I guess I need to run this. So let's send a G. And so we can see this is 47 in hex, and then 0D, 0A. There's always be a 0D, 0A. But what's the 47? Yes, that's the ASCII character, the hex character for G. Let's send a string of characters. So again, I'll set for a single run, and now I'll send G and L. And we get 47, which is G, for, let's see, for E. It's a little hard to see here. That's a 4E, and so that is a N, as we can see here, and then a 4C, which is the L. Okay, so this is the this is just sending. So let me go back to this mode, and let's exit this. And now let's go ahead and grab the feedback program. So we'll go back to the web and back to our site, and so we'll get the feedback loop here. I promised I would mention this, and I didn't. I forgot. So if this didn't run for you because you're missing serial, I'll just say we need to go sudo pip install PySerial, and that should do it. I've already got it installed, so I won't do that. That does need to be installed. Okay, so let's grab our program, and let's go to the terminal. And now we'll go take this down. Sudo nano, let's call this RS232 loopback.py. And let's paste this. And very similar setup, although it's not going to ask for user input. So I'm just going to have it send GNL again, and that's being done here. Notice we now have both the pin 56 and 57 active in this program because we're going to be receiving as well. So as the signal will come into our UART to RS232 and then get converted to plus or minus 9 volts, and we'll see that on the oscilloscope as well. But then we will also see it come back on the receiving end. So let's go ahead, and I don't think there's much more I need to say here. A lot of just error handling and stuff like that. So let's exit this, and now let's go ahead and run this. Oops. And so we'll run this first, and then we'll go over and look at the scope as well. So just a couple of print statements will pop up here, and then we see that we're attempting to send this GNL followed by a carriage return and a line feed, and then it's going to wait for the loopback, and then it's going to attempt to read, and it received the same thing we sent, so we get a successful receive, and then it just closes the port. So this is just a one-shot deal. You can go into that code and change it to whatever message you want to send. Let's quickly look at the oscilloscope, and we'll resend that. So I'll fire up the oscilloscope, go back to a single run. So I will now just run that program again. What we should see is GNL pop up on the oscilloscope. So let's run that. And we didn't see it. Okay, let me check that. And I'll pause and check that. Okay, not sure what was going on there, but it's working. So let me run it again. So there it pops right up. So all I did was run that same loopback program again, and I think we've already seen this. So 47 in hex is G, there's 4E, that's N, there's 4C, that's L, and then followed by the carriage return and the line feed. Okay, so I think that's it for looking at how these systems talk to each other. So what we'll do from here is in the next video, we'll actually communicate. We'll get away from just a single LuckFox. So hopefully you can come around and watch that video as well.